Welcome to Physics Power by Menna and Aseel.
Today we will discuss the four fundamental forces of the universe.
Before we start, please subscribe and like the video.
There are four fundamental forces in the universe, and they are
Electromagnetic,
gravitational,
strong nuclear,
and weak nuclear force.
Electromagnetic force. First of all, it's a force that occurs between electrically charged particles such as electrons and is described in electrostatics as being either positive or negative. Objects with opposite charges produce an attractive force between them, while objects with the same charge produce a repulsive force. The electric force between these two particles is what's known as the electrostatic force. This attraction describes how protons, which are positively charged in the nucleus, and the orbiting electrons, which are negatively charged, from just leaving the atom. The electromagnetic force is carried by particles called virtual photons. Two negatively charged electrons will exchange these virtual photons and push each other apart. It's responsible for the atom that holds all of us together, hold the universe together. It's also very common in our technology.
Gravitational force is a force that attracts any two objects with masses. We call the gravitational force attractive because it always tries to pull masses together, it never pushes them apart. Newton's law of universal gravitation is usually stated that every particle attracts every other particle in the universe with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Admittedly, you don't have a very large mass, and so you're not pulling on those other objects. And objects that are really far apart from each other don't pull on each other noticeably either, but the force is there and we can calculate it. To calculate gravitational force, we use a formula where we multiply the gravitational constant, which is 6.67 times 10 to the power of negative 11, by the mass of object 1 and the mass of object 2 divided by the square of the distance between the two objects. An example of the force of gravity is the gravitational force that holds the planets, stars, and the galaxies together.
The strong nuclear force is the force that holds most ordinary matter together because it confines quarks into hadron particles such as the proton and the neutron. As its name implies, it is the strongest of the four forces. However, it also has the shortest range, meaning that particles must be extremely close before its effects are felt. If you consider that the nucleus of all atoms except hydrogen contain more than one proton and each proton carries a positive charge, then why would the nuclei of these atoms stay together? The protons must feel a repulsive force from the other neighboring protons. This is where the strong nuclear force comes in. The strong nuclear force is created between nucleons by the exchange of particles called mesons. This exchange can be linked to constantly hitting a ping pong ball or a tennis ball back and forth between two people. As long as the mesons exchange can happen, the strong force is able to hold the participating particles. In everyday life, we don't see examples of strong nuclear force because it deals with objects that are really small. However, all elements heavier than hydrogen are examples of the strong nuclear force.
Weak nuclear force is the mechanism of interaction between subatomic particles that is responsible for the radioactive decay of atoms. Particles interact through the weak interaction by exchanging force carrier particles known as the W and Z particles. These particles are heavy with masses about 100 times the mass of a proton, and it is their heaviness that defines the extremely short-range nature of the weak interaction and that makes the weak interaction appear weak at the low energies associated with the radioactivity. In radioactive decays, the strength of the weak interaction is about 100,000 times less than the strength of the electromagnetic force. However, it is now known that the weak interaction has intrinsically the same strength as the electromagnetic force, and these two apparently distinct forces are believed to be different manifestations of a unified electro-weak force. Like strong nuclear force, in everyday life we don't see examples of weak nuclear force because it deals with objects that are really small. Beta decay is just one example of the weak force. In beta decay, a neutron disappears and replaced by a proton, electron, and neutrino.
Thank you for watching our video.
We hope to see you again in our next video.